this video, we're going to start doing some more algebraic stuff with our trig functions, like solving equations and simplifying expressions and stuff like that. And the first thing we're going to think about here is a question that we actually asked you a couple of units ago on the test. And it was something like, if tangent theta equals 1, which of these could be the value of theta? And that was a little bit beyond what we were doing at the time, but we always figured at the very least they could plug in the answer choices. And so I asked y'all in class, like, well, what was going on with that? And honestly, y'all weren't all that forthcoming, but the people who did tell me were giving me some sort of answer like, well, I knew that the legs had to be equal because it was tangent equals 1. And so what you were really thinking there, if you said that, was that, okay, well, that's opposite over adjacent is equal to 1, because that's what tangent is on a triangle. And if that's the case, then that's going to have to mean that you multiply both sides by adjacent. See, opposite has to equal adjacent. Or think how you get a fraction to equal 1 when the numerator and denominator are equal. Okay, and so from there, it's like, well, opposite and adjacent are the two legs in the right triangle. So there's like the legs are equal. And that meant we had to be having a 45, 45, 90 triangle. And we know that those correspond to the pi's over 4. And so with that, we could, eliminate answer choices A and B and C. And so we're down to 2. So that's pretty good. Okay, but then at 3 pi over 4, we can probably just investigate what happens there. Probably the one you wanted was pi over 4, but that's not one of our answer choices. Okay, so we check out 3 pi over 4, see what's happening here. Draw ourselves a reference triangle and see, okay, the vertical leg is positive, but the horizontal leg is negative, and I do opposite over adjacent, I'm going to get negative 1. Okay, so that one's out. And so it must be E, but let's just investigate what's going on with 5 pi over 4. We draw a reference triangle there, and, well, I don't know why we would say that that was negative right there, because it's, why we would say it was positive, because that's definitely negative. It's y is down below the x-axis, and so negative over negative is going to be a positive, and then we would conclude, answer choice E. But that's actually, that process that we went through right there, that's pretty similar to what we're going to be doing as we solve trig equations moving forward in this class. And before we really get in, I want to go back to kind of the beginning of the unit circle trig discussion and do one forward before we start to work them backwards. And so I want to go back and remind you about how we used a reference triangle to find values like sine of pi over 6. Okay, so we always started with the idea of a unit circle, and then we figured out pi over 6. Okay, pi over 6 corresponds to a 30-degree reference angle. Okay, and positive pi over 6, that's just 30 degrees up above the positive x-axis. And so I draw myself my angle in standard position right there. And then I turn it into a reference triangle by going down to the x-axis. And a triangle there. And then I'm going to label the side lengths. And the hypotenuse of all of these triangles that are on the unit circle is always going to be 1, because that circle has radius 1. And then if I've got a 30, 60, 90 triangle with hypotenuse 1, then the short leg will be 1/2, and the long leg will be root 3 over 2. And then when I go to find sine, cosine, or tangent, I can use SOHCAHTOA. So I'm looking for sine of pi over 6, and so opposite over hypotenuse, where the opposite leg from that angle is 1/2, and the hypotenuse is 1. And so when we take 1/2 and divide it by 1, it's just going to be 1/2. And so sine of pi over 6 is 1/2. But now we're going to be interested in questions like find the values of x between 0 and 2 pi that make the equation sine x equals 1/2 true. Okay, so right now we can see a solution, right? I think that you can envision yourself taking the pi over 6, plugging it in right there for x and, getting yourself a solution to that equation. But what I'm going to propose is that that's not the only solution to this equation on the interval 0 to 2 pi. There's going to be another one, okay? There's another way that we could have sine of theta on the unit circle equaling 1/2, not at that place. Okay, so if you think about it, remember sine is the vertical displacement from the x-axis. And so we could also have that same vertical displacement of positive 1/2 on the unit circle on the other side of the y-axis in the second quadrant. Okay, we could, still opposite over hypotenuse would be positive 1/2 divided by 1. And so what I'm going to do is I'm kind of just flip that picture, that unit circle picture horizontally, and just look at the corresponding triangle that also has a reference angle 30 degrees. And so we'd see, it looks pretty much the same, except that horizontal leg became negative because we were in the second quadrant. And, either way, vertical displacement was still positive 1/2. So this is also going to be an x value that makes the equation true. And if we think about, like what x value that is, okay, that's still that same 30-degree reference angle across from the 1/2 leg of a 30, 60, 90 triangle. And so I'm going to say x is less than pi by that same pi over 6 angle. And so that would be 6 minus 1 is 5 pi divided by 6. And we're not going to always, put in the same level of detail when solving these trig equations, but overall that is the process we're going to take each time. We're going to kind of identify what type of triangle we're working with, and then where on the circle that, that trig ratio can happen, and then solving from there. And you'll see what I mean once we get a little bit more complexity in our equations. I think this first one's a really good example for us to start on. So cosine of x equals negative root 2 over 2. And so that's a number that hopefully at this point you're recognizing it. If you've done the homework, so you're recognizing that number. That's the type of number we get on a 45, 45, 90 triangle. Okay. So also cosine, remember that represents the horizontal displacement from the y-axis. So I'm just going to draw a little x-axis here. I'm going to draw what I think is root 2 over 2. Maybe negative root 2 over 2. So that means I've gone left that amount. So that does mean that I've got, kind of like my idea of a y-axis right there. And so if I've got a 45, 45, 90 triangle, then the height of the vertical leg is going to need to be the same as the width of the horizontal leg. And so I'd go up there. And so this is kind of like showing me what the angle's going to be. And that's what we're doing when we're solving this equation cosine x equals negative root 2 over 2, is that we're seeing, okay, there's an angle that works, okay? But again, that's not the only triangle on the unit circle that's going to have that horizontal leg, right? We could build another one down underneath it, and look like that. But what we're looking for are the angles x radians that make this true, and so that's less than pi by pi over 4, which is 45 degrees, so that would be 3 pi over 4. And then also this one that's bigger than pi by pi over 4, and that would be 5 pi over 4. And so those are the two solutions to the equation on the interval 0 to 2 pi, most specifically because their cosine is that, that horizontal leg is negative root 2 over 2. And I like this next one too. I like that we're doing this one just immediately, because in AP Precalculus it's going to be important that we are ready to apply trig identities when necessary to simplify something down to something that we're able to solve. Because what we really want is sine or cosine, or maybe tangent, we can do a tangent, equals some number. Okay, it doesn't really matter what's on the inside of the parentheses, so I'll show you how to work with that later when it's more complicated than just like sine x. Okay, but for now we've got secant x equals 1. So we need to rewrite this because we're not just good at thinking about where secant is 1 on the unit circle. Or if we are, then you probably don't need to be watching this video. You need to be just working on the practice problems already. So if you know that secant is 1 over cosine, which you need to for this course, we'll be all right. We can figure this out. Okay, so we're going to say 1 over cosine x equals 1. And me personally, I like to think about flipping both sides of this equation. Okay, the 1 on the right is going to be a 1 over 1. Okay, well, this just means cosine x needs to equal 1. But if you want to multiply both sides by cosine x and then, do that, that's just as good. You're going to end up with the same thing. Cosine x equals 1. So now once we get it down to trig function equals number, then we're going to think about the unit circle. Let's think to ourselves, all right, on the circle, where is cosine equal to 1? Where is my horizontal displacement from the y-axis? Positive 1. And that would be on the far right edge of the circle. So that's right there on that right spot, which is theta equals 0 and theta equals 2 pi. Now, if you go and you look back, you'll see it's going to request values of theta that are between 0 and 2 pi, including 0, but not including 2 pi. So we're going to say, all right, this is just x equals 0 and not 2 pi. But At least in my class, if I am only requesting them on 0 to 2 pi and I'm not including that, and you include 2 pi and it's true, but it's not part of what I asked for, I'm not going to be penalized for that, right? Just as long as we're not saying things that are untrue. If you said like 3 pi, then that might be a problem, you know. Now the next one I've got, and it's, you know, not that much different, but it does have a little something else, okay? We're going to have to take a step first to isolate the trig function, and we are going to need to do that every time when we're solving these trig equations. So I figured I'd start us out small. We're going to look at this tangent x, and we need to solve for it first. So we're going to do that by subtracting the 2 from both sides. We'll make it nice and easy. So we're going to subtract the 2, and we're going to say tangent x equals negative 1. Okay, and so if we've got tangent equaling 1 or tangent equaling negative 1, we already talked about that in this video, we're going to need to have legs of our right triangle having equal length, okay? Maybe in this case, one's going to be the negative of the other, okay? But we're thinking 45, 45, 90 triangle, okay? And so we're thinking 45, 45, 90 where one of the legs is positive and one of them is negative. So that's going to be the second quadrant where x is negative and y is positive, and the fourth quadrant where x is positive and y is negative. And so we just draw ourselves a little diagram and say, yes, okay, if those are 45, 45, 90 triangles and the legs, the red side lengths are equal in length, okay, and one's positive and one's negative, we're going to have tangent x equaling negative 1. And so we just think about what those x values are, what those, you know, usually we would think of as the angle, and that's going to be pi minus pi over 4 for the one in the second quadrant. That would be 3 pi over 4. And then for the second one, that's almost all the way back around to 2 pi, and so that would be 2 pi minus pi over 4, and that's 7 pi over 4. And so we go off to the side and we report our solution. But, you know, I want you to think, especially that one that's 7 pi over 4, that there's another name for that theta value, right? That spot on the circle right over there. And, you know, that would mean that there are other solutions outside the interval 0 to 2 pi. And I think this one's nice because it's pretty obvious. Like, oh, this is like negative pi over 4, right? And if you think about just plugging in negative pi over 4 into tangent x, we should just take tangent of negative pi over 4, which would cause us to do that same calculation, and we would get negative 1. And so there are a lot more solutions to these trig equations if we're willing to look outside the standard 0 to 2 pi interval. So that's going to kind of bring us to the idea of finding the general solution to a trig equation. And if you're following along my notes and you're looking at like sine squared, I'm going to come back on that here in a couple of minutes. But right now I want to find all solutions to the equation sine theta equals negative root 3 over 2. So I think really ignoring the fact that we have the negativity there, I just want to think about when sine is root 3 over 2, because I just want to model this equation solving process. Okay, we've already got it isolated. So that would be with a 30, 60, 90 triangle, right? And it's when the opposite over hypotenuse is root 3 over 2 divided by 1. And we know that root 3 over 2 is the longer leg, so it's across from the greater angle, which is going to be that 60-degree reference angle. Okay, so we know that we need to have a 60-degree reference angle, and we need to have sine be negative. So if you remember all my students take calculus, then we could kind of speed that up a little bit. We could say, all right, well, sine's going to be negative in the third and fourth quadrants where tangent and cosine are positive because of the first two. All of them are positive and then sine's positive. So you could say, all right, it's 60 degrees down there. That's one technique. Or we could just keep going onto the unit circle and draw ourselves a couple of triangles, by looking for those 60-degree reference angles underneath the x-axis, and then drawing our triangles here and there, and noticing, okay, we've got these 30, 60, 90 triangles where the vertical legs are the ones that are longer, the root 3 over 2 length. Now, what I'm not pointing out while this is fresh on your mind is, like, I could also have done this same process by just thinking sine. That's the vertical distance is negative root 3 over 2, which is pretty close to 1 in terms of, like, unit circle terms. And so I could go really far down there and think about which points on the unit circle have that, far downness. What are that y coordinate? And I would say, all right, well, it would be about here and there, it looks like. And so, looking at those and thinking critically, knowing it has to be a 60-degree reference angle, I'm going to know that that's theta equals 4 pi over 3 and 5 pi over 3. Okay, but this said find all solutions. So we really are interested in all angles that are coterminal to 4 pi over 3 and 5 pi over 3. And remember, coterminal angles are always separated by an integer multiple of 2 pi. So that would be, we'd just say 4 pi over 3 and 5 pi over 3 plus 2 pi n, where n is an integer. Okay, and we don't need the fancy symbol or anything. We can just say it's an integer. And that thing, that box there, that's what we're going to call the general solution to a trigonometric equation. The one that's got the 2 pi n or some other number of n's, as we'll see here in a second. All right, now the next one is, here we've got another tangent equation. And this is one where we're going to bring in the other thing that can happen. Because we've talked about where tangent equals 1, we've talked about where tangent equals -1, but not one of these. So if we run into something where it's like tangent x equals root 3 over 3, and you just know what to do, well, good for you. Okay, proceed, because you know what to do. But if you're not sure what to do, I just would encourage you to think back to our types of triangles, right? Okay, this is going to come from one of our special right triangles. We've got our 45, 45, 90 triangle. That's not that one. That's 30, 60, 90. But we've got these two special right triangles, right? And so the 45, 45, 90 triangle, if we look at tangent, that's where we're going to get tangent equaling 1 or maybe possibly -1 if some of the side lengths are negative. Okay, but the root 3, that comes from a 30, 60, 90 triangle. And we would get root 3 over 3 by taking 1/2 and dividing it by root 3 over 2. That's like 1 divided by the square root of 3. And then you rationalize the denominator. Hopefully you've done that enough times. If you've done the homeworks in this class, you've definitely done that enough times. You know where you get root 3 over 3 from. That's from taking 1/2 and dividing it by root 3 over 2. So if we're looking for where tangent x equals root 3 over 3, and we see that square root of 3, and we know that means a 30, 60, 90 triangle, and we think it's either going to be, which reference angle is it going to be? Well, looking at this, it's going to be a 30-degree reference angle. Okay, so that gives us one solution to the equation right there. That would be x equals pi over 6, because that's an angle right there, just looking at that triangle. But then if we go to the, think about the third quadrant where x and y are both negative, and I think about that 30-degree reference angle, or I think about all my students take calculus where tangent is positive, okay, that would be -1/2 here, and this would be negative root 3 over 2. And again, if I do opposite over adjacent, I'm going to get negative over negative is a positive 1 over the square root of 3, which you simplified to root 3 over 3. And so that's going to give me another, spot on the unit circle. That would be x is pi plus pi over 6 is going to be 7 pi over 6. Okay, so you might just say, okay, well, I'm just going to report these and add 2 pi in, and I'll have a general solution because it asked me for all my solutions. And I guess that would work, but in a multiple choice environment, you need to be able to recognize an equivalent form of this, okay? And if you notice, first thing I would point out is that these two solutions here are separated by pi worth of rotation. They're directly across the circle from each other. And that's how all the solutions to these tangent equations are going to be, because the period of tangent is just pi. So what we could do is we could collapse these two down and just say x was equal to pi over 6 plus pi n. Because, when n equals 0, that's our first primary solution. X equals pi over 6. And then when n equals 1, that's pi over 6 plus 1 pi would be 7 pi over 6 right there. And then when n equals 2, that's pi over 6 plus 2 pi, which is all the way back around to pi over 6, which is kind of like what you would have been requesting in the first place if you'd written pi over 6 plus 2 pi n. And so that's going to capture all of the same solutions there. And so I think the message with that example was kind of like with the tangent equations, we find one of them and just add pi n. So find all solutions to the equation 4 cosine x plus 9 equals 5. We need to isolate that cosine x. That's going to be the first order of business. So we're going to start by subtracting 9 from both sides and then dividing both sides by 4, and we'll see that cosine x equals -1. And once we get it down to trig function equals number, we can go to the unit circle and start to think about, where is the horizontal displacement from the y-axis? -1. Okay, that would be all the way at the far left edge of the circle. And, thinking about angle-wise, that's pi. So my solution is going to be x equals pi, or any angle coterminal to pi, so that would be pi plus 2 pi n. N is just some sort of integer. All right, now we're going to talk about some inequalities, and that's something else that we need to be able to solve for AP Pre-Cal. Not nearly as much as trig equations, but we do need to be able to think about some inequalities. So we're going to start by thinking about find the values of theta on the interval 0 to 2 pi, where sine theta is greater than root 2 over 2. And for this, I think that the inequalities are pretty much always going to be presented to you like pretty much like this, in a very standard way. And so we're just going to go straight to the circle and think about it, in terms of angles and stuff. Okay, so we're thinking root 2 over 2, that's a 45, 45, 90 triangle, so we're thinking it's got to be a 45-degree reference angle. It's got to be one of the pi's over 4. And if sine is greater than positive root 2 over 2, we're thinking vertically, we're going up positive root 2 over 2. So we're going up to these 45-degree spots right here and right there. Okay. And if we're thinking about where sine of theta is greater than root 2 over 2, well, the vertical displacement from the x-axis has to be greater than it is at those 2 points. And so that would be up through here. Okay. Now, this first spot, this is theta equals pi over 4, and that second spot over here, that's theta is 3 pi over 4. And so if we want to know where sine is greater than root 2 over 2, pi over 4 and 3 pi over 4, these are places where sine of theta is equal to root 2 over 2. So theta is going to need to be strictly between pi over 4 and 3 pi over 4. Now we also need to be able to solve compound inequalities like this one here, like 2 sine theta greater than negative 1 and 2 cosine theta greater than positive 1. And I changed it from the way it might look on your notes book. I think this is going to look a little better for the video. And so for these, if we're presented 2 of them, we need to solve both of them, isolate the sine and the cosine. So we're going to divide both of these inequalities by 2 and get sine theta is greater than negative 1/2 and cosine theta is greater than positive 1/2. Okay, and so I'm just going to kind of grab 2 different colors and attack these 2 different ways. Maybe I'll do cosine theta is greater than positive 1/2. All right, so cosine is a half. A half is not very much on the unit circle. It's like the first thing greater than 0. So I'm going to just go over a little bit. It's going to be kind of an exaggerated picture, but, thinking about where cosine is equal to a half, that would be there and here. If I was going to draw those 30, 60, 90 triangles, they need to be really tall so that the horizontal leg, that horizontal displacement would be 1/2, would be relatively short. That's kind of an extreme picture, but I think that'll help me know what I'm looking at on the unit circle when I go to list these endpoints. Okay, I would say, up at the top, that's going to be pi over 3. And down at the bottom, looking at the interval, I think we're going to want to call that negative pi over 3. And that's kind of generous. Oh, so you can't see that. Making it so that we didn't have to split it over 0 and 2 pi. And I think I think that was actually just I was blindly copying off of something else, and it's unfortunate for y'all. But between those 2 theta values, we're going to have cosine theta greater than 1/2. And then for sine theta greater than negative 1/2, well, sine is the vertical displacement, so I'm going to go down 1/2, which, I know is more than that in reality, but in the unit circle world, if I draw it a little bit more exaggerated, it's more obvious what I'm looking at. All right, so sine theta is greater than negative 1/2. Well, sine theta is equal to what's that? Sine theta equal to negative 1/2 here and there, which is theta equals negative pi divided by 6 and negative 5 pi over 6. But really, we're just going to think about shading through here on that. That's what we're going to be mainly interested in, is where they were overlapping, because we want it's like where they're both happening, one and the other. Okay, like that. And that'll be through here where we're seeing overlap. And so that would be between negative pi over 6 and pi over 3. Let's say theta is between negative pi divided by 6 and pi divided by 3. Because both of the inequalities were true simultaneously. All right, now this is already kind of getting to be like a little long in terms of videos, and so I think I'm going to cut this one here, and I'm going to collect all of the other examples that I was kind of saving for the end, the slightly more advanced trig equations. I'm going to record those separately. So that's going to be all for this video. If you're watching to, prepare for quiz 8-1 or whatever, you're going to need to watch the second half, which I'm sure I've got ready on screen right here. So, move on to that one. Thanks for watching this one.